Thank you, ladies and gentlemen. The reason why I did this video is to act as a guide because I understand we are all from different backgrounds with different skill sets and skill levels. So this was for the video for the person who asked, yes, we have the data, but what to do with it, to give you a kind of sense of direction and what we are doing here. So I'm gonna stick to the first feature, which is feature A, developing of the bot and what to do once we have the data. So actually there are two ways to develop the RAG bot. You have the usual way, which is where everything is automated for you. You just upload the data into a storage container, then build an index, then tell the index, hey, this is my data. And Azure OpenAI will do everything for you. By everything, I mean it will take in your data, pass it, extract the text, chunk it, vectorize it, then stores your vectors, and then connect it to the LLM, that is the model that is supposed to be grounded. Then you can generate your response all with the click of a button, but it may come in a scenario such as this whereby we need to customize our own pipeline in building the RAG or the bot that we are to use. And one thing that comes with a customization is to enable RBAC, role-based access control. So this is kind of a tutorial to showcase to the team on what to do, especially with the data. How do you get started? So we are going to build a search index, vectorize the data, then put it in the pipeline and query. On this, while we are enabling role-based access. And there are resources for this, but I understand sometimes following the resources step by step is quite hard, especially for a new beginner. So that's the reason of this video. Without wasting much further ado, let's get started at what I did later on. So as usual, when deploying any resources in Azure, what you need to do is you just create your resource group. So I created a resource group here, here RG in East US 2. So the reason why we create resource groups is so that we can organize our resources better, gather them into like one container or a folder if you suggest. Now the things that we need are inside here, the resources. So first of all, we need a storage account. This is where we are going to put in all the data. And this is where we have a key unique feature with a storage account. We are going to use data lake storage. So what is data lake storage? Data lake storage is just like the normal storage account or your normal blob storage, but with a hierarchical namespace enabled. This means we have various properties attached to the folders. These are permission properties. If you come from a Linux background, each folders have permission properties, whether it's read, write, executable. It doesn't execute anything on your storage container or execute any commands, but it's just like an metadata appendage to each and every document so that it can be traced with their permissions. So the hierarchical namespace feature is what differentiates, it's one of the features which differentiates a normal storage account with a data lake storage. So while creating your storage account, you need to get note of the hierarchical feature enabled, and we can do this by just showing you how to create a storage account. So in your resource group, let's create one so that I can show you the difference between a storage account and a normal data lake storage, a normal storage account and a data lake storage account. It all comes with the permissions, and which is what we're trying to do here. We're trying to factor in role-based access. So on creating a storage account, we select the service, which is just a Microsoft Azure service. Then we create it. I'm not going to create the whole storage account for you. I'm just going to show you the processes on what differentiates a normal from a data lake storage account. So as you can see, I've chosen my group. Let's choose like a unique name for an example. Then we go on to next. Don't hurry and click review and create. Just go on to next. This is the feature that differentiates it here. Enable hierarchical namespace here. So if you enable this and check this button, then you review and create, it will give you the storage account, which acts as a data lake storage, with hierarchical namespace enabled. Now, that is one key feature that we've already tackled. We've already prepared our storage account. So next thing we are going to take a look at is as a Azure service. But there's a quick guide here we can follow through in how to prepare our resources, especially for role-based access control. Remember, we need RBAC inside here. So let's look at what are the prerequisites. So we need an Azure account, which we already have. We need to create an Azure AI search service, which we will create later. We need a supported data source, which we just showed you how to do it. We need a supported embedding model. The embedding model is to convert the text into vectors, embedding. This whole process is usually done when you do the normal AI Azure importation of the data. It's done for you, but since we're doing it manually or a custom pipeline, we need to do this. Then familiarity with the wizards. We'll have some wizards which will kind of guide us in how to import our data. So what are the supported data sources? We start with Azure Blob Storage and Azure Data Lake Storage Gen 2. So what we've done, we've activated an Azure Data Lake Storage. And as you can see, we need to check here hierarchical namespace enabled, which is the same case in our other side, in our account. So once we check that, we need to also check our supported embedding modules. We need to see the modules that we will be using. We need an Azure OpenAI Foundry models, hence the need of Azure OpenAI service. And we can have embedding models like text embedding ADA 002. This is the most common model that everybody uses, but there are other text embedding models which are small, large, depending on the quantity of your load. You need an Azure AI service, multiple service account, multi-service resource. The reason why we need a multi-service resource is because it's able to handle multiple services. Let's say your documents have images. They have things that need to be, it's a scanned document, so it needs a little bit of OCR, optical character recognition, to extract the text. The normal model is just a text model, but we have a multi-service model, multi-resource, that can pull other vision models, OCR skill sets, and do that for you. Then we need an Foundry model, where the catalog, where we can check all the models that we need. We can have multi-English, multilingual. We can have a model that translates to another language, which is also a key resource over here. So the reason why we are doing this with the portal and not the CLI is to make the process simple, and there are some processes which have been done by the portal for you, like for example creating a subdomain, OpenAI resources, and other requirements. So before we start this, what are the public endpoint requirements? Secure connections in the import wizards, and we have some Python sample code to test this. But the key feature that we're really interested in here is the role-based access. Now, before we engage onto role-based access, we need to enable roles and configure system assigns in our spaces or in our services. So how do we enable role? First of all, we have already seen how to create the storage account, which is here. We've already created a storage account. Now the next thing, we need a search service. So we create an Azure search service. You can do this, create it in the same region, in the same resource group as you, and in the same region over there. Then once we done created your Azure self-service, it has been deployed and you can go to the resource. One key thing for RBAC is to check your identity. So head on over to settings in the Azure service and check your identity here. So usually this feature will be off, but you need to turn it on the system assigned tab. So what does this do? This system assigned managed identity is restricted to one per resource and is tied to the life cycle of this resource. You cannot grant permissions to the managed identity using Azure RBAC. The managed identity is authenticated with Microsoft Entra ID. So remember, we are using Microsoft Entra ID for RBAC, and this is why we are setting it up. So we can add some Azure role assignments here, but right now just turning this on is what is really needed, and on turning it on you'll get the object principal ID. Don't worry about this can be rotated, so I will change mine. Going over to the keys, we also need to set up the keys. So under settings and the keys, we set it up to both so that we can enable roles. Setting it up to both, usually it's on API keys, but we can use both in case we are using keys and we want to transition to RBAC later. Later, after full transition to RBAC, we can, restrict this and set it to RBAC control. But for now, let's set it on both so that we can have the flexibility, because we are kind of, experimenting. So once we've done that, we need to assign the following roles to ourselves in the same Azure search service. So on assigning a role, as usual, we go to I&M, Identity Access Manager, and we check out the roles assignments here. So here we can add a role here, add a role assignment, and we select it as a job function role over there. So we can search for a specific role, like for example, we need a search contributor. You can search for that, and you see we have a search service contributor and we have a search index contributor. The one that we need is search service contributor, search index data contributor, and search index reader. We need to add those roles to ourselves. So I've already done that, and for you to see how we can do that, so let me try this search index data contributor. Then I move on to next. And over here, we're going to choose the kind of, identity that we want. Do we want user group service principal, or do we want the managed identity? So it's better for you. Let me see what we did here. I've already done this, and I've already assigned some roles for this. Sorry about that. So going on to the search service, and you can view access to this resource so that I can show you the roles that I set. And the job functions roles, you set them as job function roles. So on scrolling down, these are my 3 roles here: search index data contributor, search index data reader, and search service contributor, all selected as user roles. So once this is added onto here, remember we are tightening the rules, the access of the resource based on RBAC. On our data service platform, we need to select the embedding model, which we will do kind of later. So first, let's start with preparing our sample data. I'm using ADLS generation 2, but if you didn't choose data lake source, you can still use your Azure blob storage. I'm using this because it's a new feature and the permissions are integrated on the files themselves, so we can have that role-based access based on the permissions. So let's go on to our storage, whereby we will import our files. This is our storage over here, and we need to set the permissions of our storage. So let's first of all go to the container where we are going to upload our files. I've already created a container here called docs, and it has my files that I'm using for the rugs inside. So let's select it, and first of all let's check our permissions here. So on checking of the permissions, what permissions do we need? We go and assign storage blob data reader, which is the permission that we kind of need. So here we check the permissions that I added. For you, you'll add a new permission. Here I'll just check my job function roles. Let's see the permission that I added and confirm. Yep, we have storage blob data reader, and this is a managed identity, and it's based on the search service that we created the other time. So ignore the data one, that's for another service, but this is and its parent source inherited, meaning it came from the storage account, not from the container itself, but you can add it here. Then checking it out, once we've added, then we need to upload our files in the container. And one thing you need to note about uploading our files is checking out the metadata, and we can check out my metadata on what I've uploaded. So these are the PDF files, and we need to check the metadata. Since we are adding RBAC, we need to add custom metadata to each and every file. This helps us out in especially marking each file for delete, and this is also here, and that an indexer can scan to determine the blobs that are marked for deletion, and we need to give a custom property and a descriptive name. So we've chosen is deleted and we've set it to false. Why are we doing this? So imagine in our RAG, the endpoint, the user uploads a document. Here it's added onto the container and it's added onto it's parsed and added onto the index. But later, just like you use your own GPT, you decide, let me delete this document. So what happens? This metadata here is used to track the document in the indexer. So when it is deleted, it is set, the value here is set to true here. So it marks it for deletion and it's dropped from the indexer first, then dropped from the container first. So next time the index will run, in case during that process this folder is marked as true, so the indexer won't pick it up into its index and add it to the vectors. So it's quite something simple but quite necessary for this step. So you need to do this for all your files that you've uploaded in your storage container. And I know if you have uploaded, you have a lot of files, there is a script where you can do this programmatically. Just access your container and check for every folder in the container, add a metadata key with a value of is deleted and false. Then moving on to that, if you used data lake, soft delete is already enabled, but if you don't, there's a way you can enable soft delete. So you need to go back to your storage container. Then on data migration, let's say data management here, you need data protection, and you need to enable soft delete for blobs. So what does soft delete mean? You can check out of the resource, but soft delete enables you to recover blobs and directories that were previously marked for deletion. So if a user marked it for deletion, it is marked as is deleted, let's say true, but before and it's dropped from the indexer, but before maybe you want to recover the same document, so you can enable soft delete and you are able to recover. As you can see, it keeps deleted blobs for 7 days. After 7 days, you can recover the document, the PDF or whatever it is that you want to pass. So once we've enabled soft delete and we've already added metadata, custom metadata, whereby we've added is deleted and we've set it to false, we need to prepare an embedding model. How do you prepare an embedding model? First of all, we start with Azure OpenAI, whereby you need an OpenAI resource. So going back to our resource group, as you can see, I've created an OpenAI resource in the same region. We here add open resource, and also in the open resource we also need to check for the permissions that we've set. So remember, role-based access, the first thing you always check is the access. So what the access do we need to add here? Cognitive services, OpenAI user, and select the user, which is usually us. So let's check at my job function roles. You see the access that I added, and here it is. So we have, forget the last one, we have the hard AI search, which is an OpenAI managed identity, and cognitive services OpenAI user. So already that's set up just as per the instruction. Then we need to sign into Azure AI Foundry portal, select our OpenAI resource, and add a supported embedding module. So what does this mean? Let's mark our resource. So what is our resource? We already have had OpenAI, which is an OpenAI resource, and we need Microsoft Azure Foundry. So the Azure Foundry is where we have our resource inside here. And on doing this, Microsoft Azure helps you to create a resource group, that is a project folder. First of all, let's go to here. You'll see a project folder created. This comes from Microsoft Azure AI Foundry, and a resource created inside that project folder. So this might be quite confusing, but these are automatically created for you in Microsoft Azure AI Foundry. So inside here is where we will deploy our text embedding model, and I just want to show you that. For example, let's go to here. So this is my Azure AI resource, and we need to check for the models here. So you can go to I've already deployed a model, but you can go and add and deploy a model, and this is the model that I've chosen. So once you've logged in into your Azure Correct Azure AI resource, you can just go to deploy model or model catalog and choose a model that's suitable for you. These models are already there. So I've already deployed my embedding model, which is the text embedding model ADA002. And you can see that is the one which I'm going to use to vectorize. Now, once you've already deployed your model, your vectorized model, you also need another model, which is the chat GPT, the chat completion model itself. You can also go, the same process is just here, go to the same project that you are using, that you are connected to, and deploy a chat model here. The reason why mine is not here is because I've deployed it in another region, in another resource, due to quota issues. But for example, you can go here, deploy the base model, and choose, for example, I'm going to choose 4.0 mini. We're going to take some time. Yeah, there we go. Then we're going to select that mini, and no, that's quite 4.1. I want 4.0. So they're different models with different capabilities, different resources. Please keep checking on the benchmarks. They're usually ranked. There are some models which are good for scientific knowledge, some which are good for legal knowledge. So on deploying my model, as you can see, I'm taken on to Sweden Central, and the reason for this is because I can't use my resource due to quota issues. As you can see, my resource location is Sweden. But for you, if you're doing this, you won't be having quota issues unless you've deployed enough models before and you've exhausted your quota. So as you can see, I have no model in the quota here, but this does not stop our experiment. So you can just select another resource or another region here so that you can have the model over there. So once I have my two models, text embedding and the chat completion model, which will be chat GPT or something else that you choose, I've already set that up and I'm ready to start the wizard. So starting the wizard will mean I will go to my Azure AI search service. I will import and vectorize data. Here depends on what you chose as your Azure storage account. So if you set up data lake, it will be taken here. If you set up blob storage, without hierarchical namespace, which is not data lake, it will take in here. So let me show you an example. For example, I set up data lake, but I'm going to choose Azure blob storage, and let me show you what happens. If I go and select a storage account, as you can see, nothing appears here. And you might wonder, hey, what's going on? I created an account here. It's because it already told you it's the wrong account. So it's one way of checking also whether your account is enabled. The storage account has hierarchical namespace enabled. But you can check it earlier so that you don't reach this stage and get quite blocked. For example, if I choose the data lake, then I'm going to choose RAG because I'm developing a RAG. So this will do this. And as you can see here, my storage account is now available right here. So breaking onto this, we can take the blob here, which is our docs here, and here is a matter of access. So we can say enable deletion tracking. So we want to see which items are deleted and which items are not. And do you remember our deleted columns? It's just the usual. We have is deleted here. And how does it track it? We set it to true. So if is deleted is true, it's when it picks it up. And also here, authenticate using managed identity. This is a crucial step, authentication using managed identity, and leave it at default system assigned. Without this here, nothing will work. Your model will fail, your pipeline will fail to connect to the storage account, and you can't ingest any data. So you can't do anything. So please make sure you set these fields correctly over there. Sorry for that. Now, once we've set our index correctly, we need to check what's going on. So we go back to the index. Sorry about that, we fell out a little bit. Then we check our data. So we were importing and vectorizing, creating our index. So you need to import and vectorize. We already selected our data lake, we selected a rag, so we selected an account here. We selected a container, which would be docs. What else do we need here? Yeah, we need to enable deletion tracking, and we need to enable the marker, so we can say is deleted, and we set it to true. Then we authenticate using that and leave it at system manage. Then we can go on to next. So it will validate my data source connection. Here is where it will check the connection and not throw an error to see if I have the right permissions and everything set up. So while as it's validating, we can check the other resource. Yeah, it's already validated, and now it's time to vectorize my text. So what does this do? This is where we go to our OpenAI service and the text embedding model comes through. So if you set everything up here correctly, you will have this option of an Azure AI service, OpenAI service that we created earlier, and it has model deployment activated. So we can select our model, which was text embedding 002, and we can select the system managed identity. We don't want to use keys. We want it to be managed by the system. Then I agree with the pricing. You can check out the pricing there. So it's gonna cost you every time to vectorize your text, which normally happens when you go the normal path, but it's still going to cost you this time. So that indicator is just to show you. So here is where we've added other things into the indexer that we're creating, whether we want to vectorize images. So here is where the multi-model service account comes in, or whether we want to just extract text from our images. So it may depend, maybe your text contains a lot of images and you want to put those images into context. This is where you can do, or whether you want to extract text from images. This can be quite useful for me, and this is what I'll have to do. So as you can see here, my account is not being picked and I'm being told create a new service. The reason why we are being told to do this is because I don't have a multi-service account. That is an Azure multi-service account that can deal with text and images. So in case your data has text and images and you really want to put that into context, this is quite a thing that you should have already known and strategized and configured it earlier before. That's the disadvantage of using the portal. You have to follow the steps and reach the end for you to realize, oh, I've messed up somewhere. So authentication type, as usual, system assigned identity, and I acknowledge using Azure service. So what happens in advanced setting? This is where we enable the semantic ranker, and this is quite good. It helps you to rank the chunks of data that are in your index, which one is more relevant to you. So it's a feature which is can be enabled here by the check of a button, but what goes on behind is quite a good complex algorithm which Azure has kind of abstracted for us here. So it's kind of optional, but we prefer if it is inside there. And index fields. So we can preview and edit the index fields that have been passed from our document. So let's check it out. We have the default index fields here. We have the chunk ID, parent ID, chunk, title, text vector. This comes with the embedding modules, and we can check out whether our custom metadata was picked. So we can select here if you were to add another field. So these fields can't be edited later, even after you create your indexer, but you can add other field. And yeah, it's good. As you can see, we have is deleted here, which was picked later from our metadata. So let me just delete that and leave everything at default. Then I can click on next. Here I give my indexer a name and let it run. My run schedule is once, but you can set it to run twice daily or run when a new document comes in, depending on your schedule here. So I've already done that. I'm not going to create an indexer for right now because each such service is costly. It costs while it's running. So my pricing tier, by the way, it's basic. You can choose. The free tier will be quite limited depending on the number of documents that you have. So that's why I chose basic. So after everything is done and everything is okay, what do you expect to see? Let's check out my indexes. you expect to see an index like this, which already has been run, everything queried, and this is what comes into my index. You can see the data. My quota storage is around 21.55 MB, which is quite small. I don't have a lot of documents here. Let's check out my indexer, and this is what has run successfully. How long did it run for? It ran for 14 minutes. As you can see, I had some initial trials with authentication issues. So this is what happens when something isn't connected quite well. You get authentication issues and your indexer won't run. It takes 2 seconds, then fails, and you have to now start debugging where is the connection, where is the problem. So I can query my indexer, and let's see what information can come up. So since it's a legal assistant, so can I say, what do I do when my grandma dies without a will? Sorry, grandma. Boom, we already have results, and you can see the confidence score here. So we have key, text, highlights, and the score. So we already have index, and you can see the text has been chunked, so it brings about quite a lot of documents here. Let's just go to view, query options, then I hide. I need to hide this so that I can make it more readable. And then let me search again. Yeah, that's a little bit readable. So as you can see, we have the chunks, and we didn't set k, which is the nearest neighbor, so we can edit that JSON view and set, let's say, k to 5 to pick the nearest neighbor, which is around 5. Need to put quotes on that. Sorry about that. Super. Then I can search that, and you can confirm most of my data has been picked up. K is equals to 5 over there. That is the question, and what the scores are here. So later I'm going to show you how this will appear in the chart, especially passing this context into the chart playground. Yeah.